When Eric Evans wrote about the repository pattern in 2004, Entity Framework did not exist. Evans described the pattern as a way to remove storage concerns from the domain model. The idea was that application developers would implement storage logic within a specific repository implementation so that they could encapsulate persistence technology. This kept the bulk of the application focused on the domain model. A repository provides the illusion of an in-memory collection of objects. The application retrieves objects from a repository that meet a given specification. As Evans described it, a specification is an object that describes a set of criteria. An entity either satisfies the specification or it does not. The specification and the repository work together to query the persistence mechanism. If the persistence is in SQL, then the specification needs to generate the right where clause to pull out the matching entities. Now that we have ORMs like Entity Framework, we would never consider writing code like this. Entity Framework query providers have taken on the responsibility of generating SQL for their specific persistence mechanisms. The specification for which they generate that SQL is a link expression. The same link expression can produce different query syntax based on which storage technology is used, but it always means the same thing conceptually. Even though we don't implement repository and specification in the way that Evans wrote about them in 2004, these patterns continue to have value. We still want the illusion that our entities are sitting in a collection, ready for us to pluck them out and start using them. And we still need a way to specify which entities we want to work with. And so, these patterns remain popular, albeit with modern implementations. The specification pattern has evolved into an object to encapsulate link expressions. Steve Smith maintains an open-source project called Specification that implements this pattern. An application developer declares a class that inherits from a generic abstract base class and provides a query. The specification object encapsulates a link expression. Tim Rayburn and Devlin Lyles maintain a different open-source project called Highway Data. With this library, the application developer inherits either the query or scalar generic abstract base class, and then they supply a context query in the constructor that operates on an iQueryable in order to build a link expression. Both of these libraries solve the problem of encapsulating the sometimes complex query logic so that it doesn't pollute the domain code. But they leave the work of interacting with the persistence mechanism to the query provider. In the Pluralsight course, Entity Framework in the Enterprise, Julie Lerman dedicates a module to Entity Framework encapsulation. In that module, she addresses the great repository debates. The repository keeps ideas about data storage from leaking into the domain logic. All that the domain consumer needs to know about is that they can query, add, modify, and delete entities in the repository. Julie explores the pros and cons of different implementations of repositories from the perspective of encapsulation and providing the right abstraction. Please see her course for that deeper dive. In today's Entity Framework, DBSet provides the illusion of a collection of entities ready for us to use. It plays the role of the repository. Link expressions give us the means to express a specification for the entities that we want to work with. And query providers abstract away the details of the persistence mechanism. Developers need to know about these details, but the domain-focused code does not. More and more, Entity Framework has become the best implementation of the repository and specification patterns that have been developed. And so Carlos decides that he and his team will simply use Entity Framework as the repository. DB-Context brings together a group of related DB sets in a unit of work that our domain logic can depend upon, which brings us to the final question. Where do we declare the DB-Context derived class? Is it in the infrastructure layer? Or is it in the domain layer? Is it appropriate that our domain logic knows that it's using Entity Framework? Does that detail need to be abstracted away behind a repository interface? Experts do not agree on this question. The arguments that you'll see for using repository include isolating your database-oriented code, mocking and testing, using non-Entity Framework data sources like Dapr, caches, or certain NoSQL databases, and enforcing domain-driven design concepts like bounded contexts and aggregate roots. Arguments that you'll see against using an additional repository abstraction include hiding of important performance levers like change tracking, graph traversal, and deferred execution, overfetching of data inside of the repository that ends up not being used in the domain logic, and an added layer of complexity. Carlos considers these pros and cons, and he decides that he can get the benefits of a repository in different ways. First, he can isolate database-oriented code by using query and command objects that operate directly against a DB context. And second, for testing, he can use the in-memory query provider for unit testing code that depends upon a DB context. And, should he ever bring in a non-entity framework data source, he doesn't mind building a repository abstraction around that piece of code. There's no reason that all data sources should be behind repositories. And then finally, as for domain-driven design, Carlos recognizes that domain-driven design is first and foremost a framework for communicating about problems and solutions. It's not a set of hard and fast rules for how to implement a software system. And so, while it would be tempting to impose rules like 1 DB context per bounded context, and DB sets only for aggregate roots, he knows that that's not in the spirit of DDD. Instead, he decides to enforce those concepts with code reviews and regular team discussions. And so Carlos arrives at the conclusion that it is perfectly acceptable for the domain layer to define a DB context. He does not need to abstract it behind a repository. This is a decision that does not align with generally accepted best practices, but it is a defensible and justifiable position nonetheless. We'll indicate such decisions within this course with Carlos prefers. Carlos prefers to define the DB context in the domain layer. He uses the infrastructure layer for choosing and configuring the query provider. Taking all of these considerations into account, Carlos has settled on a particular project structure. Starting at the bottom, the shared kernel project includes all of the base classes and interfaces that will implement cross-cutting concerns. Because these base classes and interfaces are likely to provide services for entities, this is where we bring in the EF core dependency. But this is not where Carlos will define his entities. Those go in the domain project. Because the domain project depends upon the shared kernel, it will inherit the dependency upon EF core. This transitive dependency will allow Carlos to inherit from DB context. And in this derived class, he will configure all of his entities and their relationships. But this is not where he configures the persistence mechanism, because that's the job of the infrastructure layer. Infrastructure is where Carlos defines the migrations. This lets him separate the concerns of storage from the concerns of domain logic. This works because Entity Framework is an abstraction over the storage solutions. It's only at this level that he brings in the EF core package for SQL Server. Finally, he defines the API project. This has the usual controllers that you would expect to find in an ASP.NET Web API. It also includes the data transfer objects that define the API schema. And, as we've come to expect in ASP.NET, this is also where he configures the inversion of control container. Now, because this layer is responsible for publishing the API schema, it brings in Swashbuckle. And to support generating migrations, this is where he brings in the EF core design package. Even though those migrations end up one layer down, Entity Framework Core requires that you use the design package at the top level. And so this is the 4-layered architecture that Carlos is going for. It keeps architectural decisions separated and controls dependencies. This layering also has the advantage of being easy to test. Unit tests are run on top of the domain layer. Because Carlos prefers to define the DB context in the domain layer, that's all he needs for testing. But if you're following the more generally accepted practice of defining the DB context in the infrastructure layer, then you'll need the unit tests to depend upon that. Otherwise, they wouldn't be able to configure the DB context to use the in-memory query provider. These are performed in memory so that they're fast and easy to change. Integration tests are performed on top of the infrastructure layer. That allows them to bring in the SQL Server database configuration and make sure that things work against a real database. And then finally, end-to-end tests are done on the API layer. Because of that, they can see how services interact with one another. As Carlos and his team build the solution, they start with the domain project. This lets them focus their efforts on the problem domain and keep it separate from infrastructure concerns. Carlos has added globoticket.domain to the solution. As he fleshes it out, he's going to apply these best practices to the DB context. Use the generic DB context options, and finally, keep entity configurations isolated. Carlos has already added a reference to Microsoft.Entity Framework Core. And he's starting off by defining the globoticket context class, which inherits from DB context. As he adds the constructor, he applies the first best practice: use the generic DB context options. This class takes the context type as a parameter. The generic DB context options will help him with IOC configuration, especially if he creates additional DB context classes. He passes it to the base class constructor. Then he defines his first entity. Right now, the venue entity has an ID and a couple of string properties. There's a lot that he can improve here, but we'll save those best practices until Module 5. For now, he'll add the venue to the globoticket context. Because his team uses the convention of singular table names, he uses a singular property name. This has two benefits. First, it keeps the code consistent with the database, so that his team doesn't have to mentally switch words as they inspect the data. And second, this lets him define the entity in onModel creating without giving an explicit override to the table name. And speaking of onModel creating, that's where he goes next. And this is where we usually start building out all of our Fluent declarations. Now, have you ever been on a project where these Fluent declarations just get out of control? Yeah, I thought so. Me too. That's why we're not going to do that here. Instead, we're going to create a new class inside of a configuration folder called Venue Configuration. And this class will implement the iEntityType configuration interface. This is a generic interface, and we give it the type of the entity. And this will allow us to configure just that one entity. This will help us to keep our model configuration nice and clean. Instead of putting all of the model configuration directly inside of onModel creating, all we have to do is call apply configurations from assembly. This will scan the assembly and find all classes that implement the iEntityType configuration interface. Now, the next time I add an entity, all I have to do is add a configuration class to go along with it. And now we can follow the best practice of keeping our entity configurations isolated. And with that, Carlos has started a new domain project that is the foundation of his application. It defines all of the entities, their configurations, and his DB context. It's also where he'll define domain services, things that use the DB context to work with entities and relate them to one another. This project has no idea how to persist those entities. That's the concern of the infrastructure project. And that's where Carlos goes next.